Okay, we're going to start with adding and subtracting matrices, and I think we'll get to multiplying as well. So first thing you need to know, when you see a matrix, it's just an array. So I've got, 6 numbers in there in a certain order, so it's always row. So this is called a 3 by 2 matrix. The reason is there are 3 horizontal rows. So there are 3 horizontal rows here and 2 vertical columns. So row by column, so RC, so row by column there. And we're going to use that when we multiply and when we add. It helps to identify the dimensions of the matrix first, for sure. So let's see, this one would be 1 by 3 matrix. And this one is also 1 by 3. And so to add or subtract matrices, you have to have the same dimensions. And you just take the first item in the first matrix. So it'd be 6 minus 4, which is 2. Again, we're subtracting everything in this, so don't forget that. 3 is the second term, and so that'd be 3 minus negative 2, which is 3 plus 2, which is 5. And then negative 7 is the third term. So it'd be negative 7 minus 5, which is negative 12. So there's also, you can use the matrix in your calculator just so you know you can type matrices in. I want you to do these without a calculator, but eventually we'll get to some where you'll type them in. And so their matrix template, I think like that's a 2 by 2 template. That's a 1 by 2. That's a 2 by 1. This one is customizable. So if you go to that particular one, this would be a 1 by 3. So if we type this in, this would be 1 by 3. So 6. Let's see if we do this one right. 3 and negative 7. And then minus another 1 by 3. So I'm going to use that same template. 1 by 3. And this would be 4, negative 2, and 5. Oops, 4, negative 2, and 5. And you get 2, 5, negative 12. So when you add or subtract a 1 by 3 by 1 by 3, you're going to get another 1 by 3, by the way. Okay, so this one would be a 2 by 2. And this one is 2 by 1. And so can we add those? We cannot. So this is not possible. You get an error message in your calculator if you try to add matrices that do not have the same dimensions. It's not going to work out. Let's see what happens. So if we type in a 2 by 2, so I'm just going to go to a template here, 2 by 2, 1, 2, 3, 4, plus, I guess that'd be 2 by 1, if there is a template for that one. So that'd be 5, 6, and what to say? Dimension mismatch. So it gives you an error message because you can't do it. Scalar multiplication is exactly like you might think it might do. So it just kind of distributes it and negative 12. And it's really easy to do. It's just like almost like the distributive property for every term in there. You can also store matrices. So if you wanted to store a matrix, so this would be a way to do it. So you can actually, you have to kind of do it in reverse. So first you type in the matrix. So I'm going to do a 2 by 2. I'm going to copy and paste that one because we just did it. Delete that. There we go. So I typed in that matrix. And we use the stow key. So on the calculator in blue above variable, control variable is stow. So you're going to store that as A. Let's store this other variable, this other matrix. So I'm going to go to 2 by 2 here. 5, negative 1, negative 3, 0. I'm going to hit the stow key, so control variable, stow that as B. And now I can actually type in 2A plus 3B, and it's going to do the math for me. Right, it's going to give me my answer. Now, I could have done that by hand. In other words, I could have multiplied A by 2, so that would be, 2, 4, multiply b by 3. We're going to add that. So that's going to be 15, negative 3, negative 9, and 0. If we add that, we get 17, 1, negative 3, and 8, I believe. Is that what you got? Yes. So it's easy to make a little mistake, but you're just basically, just to make sure you're getting it, you're adding up the top left-hand corner there, and then you're adding up the top right-hand corner there, etc. 4 plus negative 3 is 1. You just keep going and add them all up, and you'll get it. It's really, adding and subtracting is pretty easy. Okay, let's go to the second part of this lesson. We're going to multiply. Okay, so this one takes a little bit more work. But first, let's talk about equal matrices. So these two matrices are clearly equal. This is a 3 by 1. This is a 3 by 1. So the dimensions are 3 by 1 and a 3 by 1. And the numbers are the same, so those are exactly alike. Now, what's interesting about this one, the numbers are the same, but the dimensions are not the same. So this is a 2 by 2. This, I guess, is a 1 by 4, right? 1 row, 4 columns. So those are clearly not the same. So to have, sometimes we'll talk about equations with matrices, kind of a sneaky way of writing a system. We'll get to that eventually. So this is really just a system of equations in disguise. And so we're just going to kind of like simplify this. So 2 must equal 2. Well, that's true. X must equal 1. So X equals 1. That's helpful. Negative 4 must equal 2y. So if I solve for y, I get y equals negative 2. So I know those two things are true, I think. And then just double check that in the last term there. So if I add up 1 plus negative 2, I get negative 1. That works. The system solution would be 1 comma negative 2. This whole chapter, writing answers like ordered pairs if they're a solution to a system, that is kind of a system in disguise. It's a different way of writing it. This one looks a little bit more challenging. You can see that those are 4 different cells. So you've got 4 different equations. I'm just going to set up the equations down low. So we'll take that top left-hand term. So it's going to be x squared plus 1 equals 5. This is going to be 5 minus y equals x. X plus y equals 5. And y minus 4 equals 3. Now, I don't know if it's obvious to you, but this last equation looks like the best one to solve because I pretty much know y is 7 now. And this one looks pretty nice, right? Because if y is 7, x plus 7 equals 5, so x must equal negative 2. So now I think I know my answer. I think it's 7 and negative 2. Let's just check. So it has to work in all the equations to be a solution. So if I plug in y here, which is 7, so 5 minus 7 equals negative 2, which works. That works equals negative 2. If I square this, I get 4 plus 1 equals 5. So I do have my answer. Negative 2 comma 7 is my answer for this one. Okay, let's get to multiplying matrices, the second part of the lesson here. So the inside dimensions. So like the dimension of matrix A is, say, a 3 by 2. Dimension of matrix B is a 2 by 3. And we're going to multiply those two matrices. Now, what you have to look at is, do the inside dimensions match? So when you line those up, because those inside dimensions match, I can. And now I want to look at the outside dimensions. So the outside dimensions determine the product dimensions. So they do. So like that's a 3 by 3. So the product, when you multiply these two size matrices, you're going to get a 3 by 3. So just to make sure we're kind of getting what you're doing here, so we go, okay, let's do like a 2 by 4 times a 2 by 4. So I know I can add those two. We just talked about that, same dimensions. Can I multiply them? Well, let's check. Look at the inside dimensions. No, you cannot do it. So if they don't match, see how they have to match? We say yes, we can, because the inside dimensions match. Let's try another one. See if you have like a 1 by 3. dimensions of the outside part. So first, I know we haven't taught you how to multiply yet, but this is like, can you multiply? So it's just a basic question about that. You can see the pattern if you want by typing that in your calculator. It'll actually do it for you. But let's just show you what it does. So it's doing row by column multiply. So first of all, this is 2 by 2 times a 2 by 2. Maybe obvious to you, but yes, we can do it. The dimensions of the answer is going to be a 2 by 2. So I'm going to kind of leave a spot here. Like those are going to be my 4 answers. I'm going to take a little bit of work to do this. So let's do this kind of one step at a time here. Okay, so top row. So this cell right here, this answer choice, is in the top row. So I'm going to circle the first matrix, circle the row. R stands for row there. So that's in the top row, so I circle the top row. It's in the left-hand column. First item in the row times first item in the column. So it'd be A times E plus the second item in the row times the second item times plus B times G. Now let's do the next one here. So this one is in the top right. So I'm circling the top row and the right column. So it'd be first times first. So it'd be A times F plus second times second. So it'd be B times H, BH. And then you could do, say, that the bottom row there. So that'd be bottom row and left-hand column. So it'd be first times first, it'd be C times E plus D times G. And then the last one is going to be bottom row, right column. So it'd be CF plus DH. Okay. Before we actually multiply one with actual numbers in it, I just want you to see the connection here. So if I were to multiply this, well, let's just see. First of all, 2 by 2. I always like to look at the dimensions first. This is actually a 2 by 1. So do the dimensions match? Yes, they do. The dimensions of the answer is going to be a 2 by 1. It is. So if I circle the top row in the first column, well, the only column, 1 times x is 1x, plus 2 times y is 2y equals 3. That's where those 3 numbers come from. I don't know if you see that. Let's do the second. So this is now the bottom row in the first column, the only column. 4 times x is 4x, plus 5y equals 6. You can see this is kind of a new way of writing a system. So this is a system, and this is for a purpose, not necessarily with this chapter, but this is where we're heading. Why are we learning about matrices? We're going to solve systems with them. That's why, pretty much. So this is called the coefficient matrix. Take all the coefficients of the variables there. This is the variable matrix. If you multiply those, you're always going to equal the constant matrix here. So those are the constants. They don't have a coefficient or variable attached. Okay, can I multiply these? Well, that's always a good question to ask. So this is a 3 by 2 times, I guess this is a 2 by 3. So the inside dimensions match, yes. The outside dimensions are 3 by 3. So I can do it, and the answer is going to be a 3 by 3. So I'm kind of looking for 1, 2, 3, 1, 2, 3, 1, 2, 3. So I've got kind of all those cells to kind of fill out here and solve. Okay, so this top left is going to be top row, always row, by column, RC. So column, first times 1 times 2 is 2, plus 3 times -4 is -12. So that first term, if I simplify it, would be -10, I believe. Yeah, -10. Okay. Top middle, so top row, middle column. This would be 4 times 1 is 4, plus 3 times 1 is 3. So that's really 7. Top right is going to be top row, right column. So 1 times -1 is -1, plus 3 times -2 is -6. That adds up to -7. So I've got that one. middle and left. So middle row, left column. So 2 times -2 is -4. Plus 0 times anything is 0. So it's -4. Middle times the middle row and column. So -2 times 4 is -8. Plus 0 times anything is 0. So it's -8. -2 times 1 is 2. Times -2 times -1 is 2. 0 times anything is 0. So I get 2 there. And let's go bottom row. So I'm going to this one here. So times first column, -2. Sorry, -2 plus 2 times -4 is -8. -2 plus -8 is -10. This is middle one, so it's going to be -4 minus 4 is -8, I think. Yeah, you're making a mistake here. This would be 1 plus -4, which should be -3. So I think that's our answer. I'm just going to type this in the calculator just to kind of double check that we did everything right. So you're going to do a 3 by 2. So 3 by 2 columns is 1, 3, -2, 0, and -1, 2 times 2 by 3, 2 by 3. It's going to be 2, 4, -1, -4, 1, -2. Okay, -10, -4, -10, 7, -8, -2. Oh, I made a mistake. And then -7, 2, and -3, -7, 2, and -3. So this one is wrong. What did I do? Okay, let's highlight those. Let's see what we did wrong here. So this is going to be, let's see, this is bottom middle, right? So bottom middle. So bottom row, middle column. So it should be -4 plus -4, right? +2. I know what I did. Okay, so it should be -1 times 4 is -4, and then 2 times 1 is 2. Oh, so it's -2. Is that the right answer? Yeah. So easy to make a mistake here, for sure, when you're doing this, as you can see. But if you're careful, you actually do okay. These multiplication commutatives. So I'm going to take those same two matrices, and I'm changing them around. We're going to multiply them, but in a different order. Well, first of all, let's check and see if we can even do this, right? So this is now a 2 by 3 times a 3 by 2. So can we do it? Yes, we can. What are the dimensions of the answer? Right away, you can tell, okay, this is not going to give us the same answer because quite literally, it's only got 4 cells instead of 9 there, I think. So definitely not going to be the same answer. Okay, so let's do this. So you go obviously row. So row pi, that's a row, times column. So first item of the row times first. So 2 times 1 is 2. 4 times -2 is -8 or -8. And then -1 times -1 is +1. So that first item in the top left will be -6 plus 1 is -5, I believe. And then we go to this one. So this is going to be 2 times 3 is 6, plus 0 times anything is 0, -2, which should be 4. Bottom left, so bottom row is going to be -4, -2, plus 2. So which is actually should be -4 there, I believe. And this one, it would be -12 plus 0 minus 4, which is -16. So let's just try this. Didn't do so well last time. Let's try it this time. So actually, I'm going to copy and paste delete the first matrix. Put a time sign here. Copy and paste, delete that one. Okay. -5, -4, 4, -16. Ah, got it. Okay. So I thought it's a little better that time. Try this one. Can you even do it, right? So let's check it. So this would be 1 by 3 times 3 by 1, 3 by 1. So yes, we can. Mention the answer. This is really weird. It's going to be a 1 by 1. So it's going to be like one item in there. So it'll be first times first is 2 plus second times second is 5b minus 36. That can be simplified a little bit. So I think the only thing in here would be -34 plus 5b or 5b minus 34. It's all one term there. It's a 1 by 1 matrix there. Technically, that's one term. Doesn't add up nicely, but it is just one term. Be really careful on this. A lot of students, I'll tell you on the front end, I'm probably going to put a problem like this, similar to this on the test or quiz. And some of you are going to, just think, like that's 1, 4, 9, 16. Got it. Boom, it's done. You're thinking like regular math. This is not regular math. This is matrix math. A squared means what? It means A times A. Oh, how do we have to multiply matrices? We have to do 1, 2, 3, 4. First, we have to see, can we even do it? But we write them next to each other. 1, 2, 3, 4. Right? And you get, let's see, a 2 by 2 times a 2 by 2. Can we do this? No, we can add them. Yes, we can. The dimension of the answer is a 2 by 2. So we're going to get a 2 by 2 here. The top left term here is going to be row by column. So it's going to be these two. So 1 times 1 plus 6. So the top left term is 7. Right column, that'd be 2 plus 8. This isn't too bad. I think I've got this right so far. 3 plus, I guess that's a 12. There's a weird looking 3 that I made. And then 6 plus 16, it's a positive 16. So this would be 15, and this would be 22, I believe. So let's see, if I take 1 by, well, let's try it just the way it's written. So that's kind of interesting. So let's do a 2 by 2. 1, 2, 3, 4. And let's square it. 7, 10, 15, 22, 7, 10, 15, 22. We got it. So be very careful on those. If it doesn't end up what you thought, 1, 4, 9, 16, nope, doesn't work. Matrix is different than regular math. This is kind of interesting. This is kind of leading towards the next lesson. Which I think at this point, we're just going to wait on this and wait till the next lesson because I think y'all are good to go on the basic adding, subtracting, and multiplying lesson. So we'll wait on this. This is really part of the next lesson. We'll get to that later.